Alright, today I want to talk about the derivative of a product. How do you take the derivative of two things multiplied together? If you have two things added together, it's no big deal at all. Like what's the the derivative of x cubed plus 4x squared? You don't really even think about this, but the fact is when you have two things added together, you just do the derivative of the first one and you add it on to the derivative of the second one. So that's 3x squared plus 8x, right? This is the derivative of two things added. What if they're multiplied? Can you just do the same thing? The answer is no, you can't. There's actually a special thing, right? What if you really tried to do this multiplied together? Well, if you really had to do this, you should just multiply them. In order to do that, it's a 4, and then the x's will combine. This is the same as the derivative of 4x to the 5, right? And this, the derivative, you bring the 5 down, you get 20x to the 4, okay? If you think it through, actually, this is not the same as what you would have got if you did each derivative separately. Separately, these would be 3x squared, and this one will be 8x, and if you multiply that, you get 24x cubed, which is not the same as this, okay? So you cannot, when you're doing the product, in this case, you actually have to do the product first and then take the derivative. You will get the wrong answer if you just take the derivative of the two things separately, all right? But there are some cases when you really want to be able to do the derivative of the product without simplifying it first. Here's an example. I lost my eraser. There we go. Okay, here's an example of the derivative of a product, right? I have these two things multiplied together and I want to find the derivative. Now, you could just simplify it beforehand so that this is not a product anymore, but that's a real pain to do. It's not terrible, but you have to do like the FOIL thing, but with 3 terms over here. It's a pain. You get 6 total things and then you would take the derivative of that, all right? It would be preferable if there was some kind of a trick that you could use to do the derivative here as is, without having to do the simplifying first, all right? There is such a trick, actually. It's called the product rule. It's how you take the derivative of a product, all right? So leave a little space here. We'll come back to this one once we know about the product rule. The product rule, this is the rule that tells you how to find the derivative of two things multiplied together. Maybe I'll just tell you what the rule is first, and then I'll explain sort of where it comes from. The derivative, so this is what it says, the derivative of f of x times g of x. This is about the derivative of two things multiplied together. So if your two things are the f of x and the g of x, what is the derivative? Here's what it is. The answer is f of x times g prime of x plus g of x times f prime of x. That's a prime right there. F prime of x, all right? So the way that I'm going to say this usually, if I'm saying this out loud, it's the first thing times the derivative of the second thing, of the two things here, plus the second thing times the derivative of the first thing. Pretty great, huh? It's got a nice sort of symmetry to it, if you will. This is called the product rule. You definitely need to have this memorized. You're going to be using this all the time. This is how you take the derivative of two things which are being multiplied together. It's the product rule. Okay, now we know about the product rule, right? It says the derivative of, f of x times g of x is the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. All right, so in this case right here, my first guy is the f and the second guy is the g. And we can just plug into the formula. Okay, so in this example here, that derivative is going to be, all right, it's f of x, so the first part, as is, times g prime. You got to take the derivative of the second part. Don't forget your parentheses there, haters. 6x minus 5, right? That's the derivative of the second part. So that was the g prime. And then plus g of x, the second part, as is, plus 7. F prime of x is the derivative of the first part. What's the derivative of that? 1. All right, there you go. This is the answer. This is the derivative of that product. It doesn't look, I don't know if you like the way this looks. I guess if you like, you could do the FOIL here, expand this and combine it with that. I don't really care though. This is the derivative. If someone asks you to find the derivative, that's your answer, right? You shouldn't really simplify it unless they tell you, oh, I don't want that, I want to simplify it. But if they don't say so, if I say find the derivative You take the derivative, you leave it at that, all right? The product rule is super important. You should absolutely remember that formula because you're going to be using it a lot. It's not as important for our purposes to remember exactly where this formula comes from, but I think it's good to see at least once in your life where that thing, you shouldn't just believe me just because I say so that that's what the derivative of a product is. Here's why that formula works out. I'm going to kind of go through this quickly. I hope you don't mind. If you're really into this, you might want to take a close look at what's going on here. Anyway, if you want to establish this formula, you have to use the definition of the derivative using the limit, and this is what it would be. All right, you plug in x plus h everywhere inside here, and then you subtract, and you just do the ordinary function, and you divide by h. Okay, in this step I did one of those crazy things where right in the middle here you have this guy is right there. In the middle I did a minus f of x plus h times g of x, and then plus f of x plus h times g of x. Since I added and subtracted the same thing here, this will still be equal to what I had before. And then here is what was there before. Why do you do that? It's so you can separate the fraction into two parts. And then you can factor out of both of these fractions here. This one, both terms on the top have a f of x plus h, so you can factor that out to the front. And then over here, both of these have a g of x, so you can factor that out to the front. And what are you left with? Check these guys out. Does that look like anything to you? I think it does. I think you know what it looks like. All right, I'm going to continue up here. What is this? You can actually do this limit now. Use the h equals 0. Here we're going to have f of x plus h. That will be f of x plus 0 times, what is that thing? When you take the limit as h goes to 0, that is the definition of the derivative of g of x. So that is g prime of x when you take the limit as h goes to 0. What about over here? Okay, the plus is right there, g of x. And then this right here is, again, this is the definition of the derivative of f when you take the limit. So this is f prime of x. All right. What about this x plus 0 is a little weird, but I mean x plus 0 is just x, right? So my final answer, f of x, g prime of x plus g of x, f prime of x. Ain't that the same thing that I said before? This is the formula for the product rule, right? The first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. All right? That's where the product rule comes from. It's just sort of a bunch of shuffling the fractions around. It turns out this is the formula. The product rule is how you do derivative of a product. There's another thing that everybody always talks about after you do the product rule, the derivative of a product of things. There's another thing for dealing with something like this, the derivative of f of x divided by g of x. All right? There's a rule for that too, okay? And again, I'll just remind you, you cannot just take the derivative on the top and take the derivative on the bottom and divide them and expect to get the right answer. Just like that doesn't work for products, it doesn't work for quotients, all right? There's a special rule that you need to deal with quotients. Anyone think you know what the name of that rule is? I think you do. It's called the quotient rule. The quotient rule, all right? It's like the product rule, only slightly more complicated, just because quotients are a slightly weirder thing than doing products. Again, I'll tell you what the quotient rule is straight up, and then I'll say a little bit about where it comes from. Here's the quotient rule. Again, you're going to have this memorized. You'll use it a bunch of times. Here's what it is. The derivative of f of x divided by g of x, you go the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. All right? This is the quotient rule. Put that in a box somewhere. Put it up on your refrigerator. All right? This is a very important thing. Like I said, you should have this memorized, so you're going to use it all the time. All right? The bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. I actually have a sort of a silly and somewhat, embarrassing trick that I use to remember the quotient rule. I'm not sure why this makes it easier for me to remember, but if you look at this fraction here, I'm going to rewrite this in the sort of the silly way. Even as I was writing this just a moment ago, in my head I was thinking of it, this stupid thing that I'm about to say to you. The derivative, if you think of these two guys as high over ho, the derivative of high over ho is ho d high minus high d ho over ho ho. You like that? The d means derivative, so ho d high means the bottom times the derivative of the top minus the top times the derivative of the bottom. And then the ho ho means the bottom times itself, right? It's like ho times ho, which is ho squared. You see what I'm saying? It's stupid, but for me it works. I don't know. Take it. I offer this to you. Okay, let's try this example here. I got my quotient rule written down there so I can use it at a moment's notice. All right, I want the derivative of this fraction. Whenever you see the fraction there, you know you're going to have to use the quotient rule. So let's do it. You just plug stuff in. So in this case, the f is the guy on top, the g is the guy on the bottom, and you do that. So it says g of x times f prime of x. So the g is the bottom as is. So my answer, this is really just one step. You just do that and that's the answer. The bottom times the derivative on top. What's the derivative of x squared plus 3? It is 2x. You better make sure you remember these parentheses there. It matters. Put the parentheses there. Okay, and then minus f of x, that's the top as is. Again, the parentheses are important. Times g prime of x, that's the derivative of the bottom. What's the derivative of that? It is 3. Like so. And then divided by the bottom squared. You don't do any derivatives or anything down here. It's just this thing on the bottom squared. Again, you need the parentheses here. There you go. This is the derivative of that. Like I always say, you could simplify that if you want to, although unless you have a good reason to, I don't think it's worth the effort. You know, it's just a bunch of multiplying whatever, right? This is a calculus class, okay? I'm going to assume you already know how to do all of that. So don't waste your time with it. Don't waste my time with it. All right? This is the quotient rule. Let's try one that's a little bit harder. This is kind of a standard quotient rule example. Let's do a fancier one. All right, here's a fancier one. You're still going to have to use the quotient rule. Obviously, it's a big fraction, so you're going to do the quotient rule at some point. What's fancier about this is on the top is also a product. All right, so this is going to be a product rule sort of on the inside of a quotient rule, okay? But at the sort of the largest level, on the global scale here, this is a quotient, right? It so happens that part of the inside of the top is a product, but really this is a quotient. So I'm going to use the quotient rule. What are we going to get? I'm going to try and sort of do this in 2 steps. But anyway, you get g of x, which is the bottom here, 2x plus 1, okay, times the derivative of the top. And now the top is a product. So when you take the derivative of the top, you're going to have to use the product rule. Just so it doesn't get too confusing, I'm just going to leave that like this. So I'm just going to say the derivative of the top is that thing. All right, you're gonna have to, like I said, you're gonna have to do the product rule here. I'll do that in the next step, just so this doesn't get too cluttered. In any case, what happens in the rest of the quotient rule here is going to be minus f of x, which is the top. That's x plus 1 times 3x squared minus 3. That was the top as is, times the derivative of the bottom, which is 2. All right, and then everything divided by g of x squared. That's the bottom squared like that. Okay? We're not quite done because I still have a derivative to do right here. And how do you do this derivative? You do the product rule. So I'm going to copy everything around here as it already is. But right there, I'm going to do the product rule. And I'm going to leave as much room as possible. All right, here we go. 2x plus 1 from before, right? Now right here, I'm going to do the product rule. Can you see me? It's the derivative. So here I have 2 parts. Remember the product rule. It's the first thing times the derivative of the second thing plus the second thing times the derivative of the first thing. Put that all in parentheses. The first thing times the derivative of the second part would be 6x, right? That's the derivative of this. The 3 goes away because it's a constant. All right, that was the first times the derivative of the second, and then plus the second part times the derivative of the first part, which is 1. Okay, this parentheses was that thing, right? That was the product rule. Other than that, I'm just copying, so everything else is the same. X plus 1, 3x squared minus 3 times 2, right? And then divide everything by 2x plus 1 squared. And that's the answer. It's a little bit long-winded as usual. If you had some kind of a reason to, you could simplify this if you want to, but I don't think there's any reason to do that. The derivative of this crazy quotient with a product inside is that big thing. That's it.